Hello, welcome to thedeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. So today we are going to solve the British Informatics Olympiad problem from 2009, round 1 in question 3. And the way that you can participate, viewers, is to write something in the chat if you have an idea of how to solve it. So I guess we can just flip to the the question. And let's go. Okay, so a toy set contains blocks showing the numbers from 1 to 9. There are plenty of blocks showing each number, and blocks showing the same number are otherwise indistinguishable. We can consider the number of different ways of arranging the blocks so that the displayed numbers add up to a fixed sum. For example, suppose the sum is 4. There are 8 different arrangements. There's 1 1 1 1, 1 1 2, 1 1 2 1, 1 3 2 1 1, 2 2, 3 1 and 4. These have been listed in dictionary order. Just like in the dictionary, where all the words beginning with an A have come before the words that begin with a B, and AA come before AB, we have listed the arrangements beginning with a 1 before those with a 2, and those beginning with a 1 and another 1 before those with a 1 and then a 2. So basically what they did is there's blocks from 1 to 9. We've got the digits from 1 to 9, and we have to try we have to try and find a way. So basically, they've listed the different ways of making a sum in dictionary order. So the problem is to write a program to determine the nth way of arranging the blocks to make a fixed sum. Your program should input integers s, then n. You should output the nth way of arranging the blocks in dictionary order to make the sum s. Wait 1 second, just can't get the pen. So then let's start. So what we need to do is just move to working out. So what we need to do is, one way of approaching it would be if we can find all the ways and list them in dictionary order, and then we can, and then after that we can do what you can just print the nth one. So we'll use. So we can use recursion. So define f of s comma n, and I think we also need to store what s is now. Then
this is an underscore?
What? This is a what?
Okay. Underscore in this.
Yeah.
Okay.
Okay, so we just have to so what we have to do is just if our s is s now, then return return the sequence, which is otherwise we can return f.
What sequence are we returning on empty list?
So what we're going to do is so basically what we're going to do is to choose the ones from, so we're going to do it from 1 to 10, and we're going to do that one plus the one we're on now. So then so when it returns back to when it goes back, when it recurses backwards, it would do the actual answer.
Okay, so this is like an empty list or what?
What's an empty list?
What are you returning here?
We're returning the sequence.
Okay.
So for I in range of 10, then
this should be 1 comma 10. Okay, how many ways are there to generate like some S?
I'm pretty sure there's going to be n choose S. Basically,
No. So we can pick one digit here and then go to S minus that digit.
So I'm pretty sure there's 1 second. And I'm pretty sure we need to return that because that's a list of all sequences so far.
Okay. So you're storing all the sequences.
Yeah, and then we're going to, because it's just brute force, we're going to do that, and then after that, and then we're going to find the nth way by just doing that of n outside the function when we
Okay.
Right, so
let's say we are at some s. What are the options we can keep at this place? We can place one of the 10 digits, 9 digits.
yeah.
So we can just go like f of s minus I, something like this.
Are you writing something on Microsoft OneNote?
Yeah, I did write something.
Yeah, I can see it now.
Maybe it will take. Okay.
So it's f of s minus I, and comma, and keep n the same, and actually it's not s minus I, because s is the sum we want.
So s now will become s minus I.
Yeah. So s now minus I.
If it's going in, you should be checking if s now is equal to 0 here then. If we're going in the reverse order.
Yeah, I guess so.
Otherwise we can just go like, sorry.
Yeah, otherwise.
Both of these are fine.
Yeah, then let's do it. So we can do stop. Let's do answer dot append off that. I mean extend, because
Will we always append?
we do what?
Will we always append?
Yeah, because then we'll get all of the thingies.
Okay, go on. If you're writing it like this, we can just start coding it, no?
Okay, I guess it's just. I'm just going to.
It's becoming a little untidy.
I'm going to remove all the code I've done. So, wait. Actually, I think what I'm going to do is just 1 second. Okay, there we go. Hey, for some reason it's not working. There we go. Okay. Right, so we already wrote most of the code for that. So define f of s comma n comma s now and if s is s now, then if s is s now, then return that. And then that's the answer for I in range of 1 to 10. Okay. And answer.extend of f of s comma n comma.
Will it always come equal 10?
No, because sometimes sometimes the sum will be, because sometimes the sum will be, so we'll have to do min of 10 on s minus s. Now I think that's probably not right. It's probably like -1 or +1 or something like that. But
It should be +1 because that digit might be included.
Okay, wait a second. There. Wait, why is it saying? Okay. Okay. S of now minus plus I, and then
Okay, what is answer here? Okay, you declared that. Okay.
Also, I shared my screen on Discord, so yes, you should be able to see what I'm writing.
Okay, I was looking at from the screen.
Come on, arithmetic error. 1 second. There. Okay, so then then just return answer. I think looks a bit small. Print out f of s comma n.
When will you append any digit in answer?
So then
We're not putting any digit in answer, I think.
Yep, so that's I'm going to just flip to that just see it. Okay. Okay, so then it'd be through this code. What the code over I did is it also stored in with store this. It stored the variable and it's for it's stored a variable for the strip to that, and we stored this answer variable. So and that.
Yeah.
Right, so and it just let's return that. So one thing that we can do is let's pull an array and then comma array plus that
Right.
And then over here will be just everything will be returned that array, and
we can just write return array. I think we don't need to return like a 2D thing.
okay. But
So we're writing .x. Okay.
Right, so wait, S is in of input and N is int of input. I think we can run it. It was 4 and 5. Why did it think?
X is missing what? I can't see the error.
There we go. Can you see it now?
Okay, F is missing an argument. Oh, in the initial call you need to pass in.
Yep, then it's comma array is just
On line 10.
yeah, 4 and 5. Okay, so all we need is that part. So then that's
It will generate all the possible sequences.
yeah, so just do that of n, and we can I think we can use this thing. It's called
It will be n minus 1.
yeah. So we can use like this. It's basically called the unpack method, and so what it does is it literally unpacks it. So if we have an array, which we do, of 2 and 1, it would say 2, then 1, then 1. So if we save and run it, 4 and 5. Yeah, we get 2 and 1. Okay, and
but if we reach the limit, let's say 31 and 2 to the power 31.
I'm pretty sure it's actually much less than that, because I remember I tested this code before, and for the input 27 and 50789789, it took quite a long time. And for 21 and I think for 21 and a million, it took quite a long time too, actually. Just a bit more than 1 second.
Can you calculate the complexity for this code?
So I guess it's for everything it's in, it splits into 10 other parts. So it's I think it's 10 to the power of s, but I'm not sure.
So the complexity for this code will be equal to the number of states that we visit, right? Like for any recursive code, the complexity is generally the number of states there are, and here for every place we have like 9 options, right?
Yeah.
So just to make it to some n, there are 2 to the power n options, yeah. So and we'll go to each one of them. So this will be exponential in time.
Nope. So and I'm pretty sure that it actually takes n times 2 to the power of n, because that plus operation is
Exactly.
It's pretty.
So can we prove on this a little?
Wait, I'm just calculating something. So for 21, it's 4404 something. You can see over here. Okay. So, and that is actually 1, 2, 3, 4, 5, 6, 7. It's about 4 times 10 to the power of 7, which is and
a lot.
Yeah, and if you sub in 27, then you get something that is much bigger than that. So it'll be it'll take a lot of time. So
can we improve on this recursion a little, so that we don't have to reach each and every state all the time?
Oh, I think one way we can improve it is to one way we can improve it is to make it, maybe we can just calculate only the state that we need, but I'm not really sure how to do that.
Okay. So let's say we place 1 at the first digit. For let's say n equals to 4. So can we calculate how many ways are there to get how many ways are there such that 1 is the first digit and rest of the digits sum up to to s minus 1.
Oh,
Let's place 1 at the first place. Now how many ways are there to make the sum equal to s for the whole array?
There's I guess then n just turns to n minus. I guess then it's we've already done one of them, so it's n minus 1. It's not n.
Okay, so if we have 1 at the first place, then if there is a function that can calculate for the where the sum is n minus 1, then our thing will be solved, right? Let's say we place 1 at the first place, then we have 3 options. There is like 1, 1, 1, 1, then 1, 1, 2, then 1, 2, 1, 1, 3. These are all the options, right?
Yeah.
So we need to write a recursive function that can make this kind of calculation.
Right.
So basically, where can I write? I'll write on the OneNote thing.
Okay, I'm going to working out.
So let's say we have a function f of n, and can you see?
Yeah, but I can only see the so I can only see the f. Now I can see f of u.
1 second, it's
on OBS you can I showed my screen on Discord so you can see what I'm writing and what I can see too.
Okay. 1 second, my iPad went offline.
Okay. Yeah, that happened.
Okay, it's online.
Yeah. I see this line thingy.
Okay. So let's say we have a function f of n that gives us the answer. Let's say this gives us the answer only. And then we have a function g of n which gives us the number of ways of making sum equals to 1. Like let's say if we pass g of 3 here, it will give us like 1, 1, 1, 1, 2, 2, 1, and 3. So the whole sum will be equal to 4. So g of 3 will actually not go to each of the states. G of 3 will just return 4. Now can we write this recursion for the g of n?
Yeah.
Okay, right.
I'm pretty sure it's just an exchange. Just choose power from. I think. I'm pretty sure that it is. It's just choose power of n.
So g of n we've already written, right?
Yeah. Okay. Actually no, but we just need to edit the code we've written a bit to make geofan. It's not really that fast.
Okay. Are you working on something?
No.
Hello?
Hello, can you hear me?
Yeah.
Okay, just checking. And I wasn't writing something. Right, so I am.
This part we have already written, right?
Yeah.
Just instead of returning the all the combinations, we just need to return the number, like the count.
Yeah.
Not and not the all possible combinations. So can you change your code so that all the combination, like the number of combinations then are returned?
Yeah. So what we can do is score. Then instead of array, we do comms. So return 1. And then actually don't need that. So and then that wait a second, it's trying to.
In this function, the value of n never changes, right? The f that we've written. So we can just strictly move n from the arguments. It has no significance here, no?
Yes, so. So no, I think it's just that. Wait, because we also need to add on. Right. Wait, no we don't. Yeah, I think that's it. Right, let's just try it for 4 and 5. Oh yeah.
Yeah.
We also have to do that. Then 4 and 5. In object is not iterable.
Answer should be 0, not empty list.
Not what?
Line 4 answer should be 0, not an empty list.
Okay. So this is 8. And let's try it for something bigger. Well, let's try the 21 and 1, 2, 3, 4, 5, 6. Okay. 8 and just okay. Okay, there we go. I'll say that error is just a keyboard interrupt because I stopped it.
Okay. So here we can just, this is like a simple recursion, right?
Yeah.
We can just like add dp to it so it will speed up by a lot.
Yeah, then I'm a dp. If it's now in dp, I think, then return dp off. Now and just dp off s. Let's go now equal answers. I don't know if this is gonna work, but let's just go ahead. Oh yeah. F of 0, comma, comma dp, command S, and 4, 5, and 21, 1, 2, 3. Okay, and let's try the 27 and something thingy. Oh, it's 27 and that.
So n right now does not matter at all. You can just put it anything.
Right, let's try again. Whoops. Okay, so 27. That. Yeah, that was pretty fast. So, yeah,
Yes.
I think. Right.
So this is working, right?
Yeah.
So now what we can do is we can let's build, okay. So let's place 1 on the first place, and then let's see how many ways are there to make these equal to 3.
I'm not sure.
1 second, I need to put my laptop on charger.
I'm not sure how to put 1 on the first place.
Just a second. Yeah, okay, I'm writing now.
Okay.
So we can put 1 on this place, and then we can see how many ways are there to make these numbers equal to 3. Is that right?
Yeah.
So this will be given. Does that make sense?
Yeah. So all we have to do is do like a number, and then run g off that g off sum minus 1. And it doesn't have to be 1, it can be anything from 1 to 9.
Yeah, so G gives us that one, the number of ways to meet that sum.
Yeah.
G of 3 give us?
From that it would give us.
You can just run the program to see what will G of 3 give us.
So I'm pretty sure
It will give us 4. G of 3 is equal to 4. 1, 1, 1, 1, 2, 1, 3. These 4 is.
So it's first S then N.
Is that making sense?
Yeah, and give us 4, yeah.
Yes. So if we know that if we place 1 at the first place, there will only be 4 answers that will come. Check for more. We can just we know that 1 would never be in this place, right? We are fixing 1 in the first place, and now we know that there are 4 coming from this, the remaining part. So we know that, and we need to make n equals to 5, right? Find the 4th combination. So if there are only 4 combinations that are starting from 1, then 1 will never be in the first place.
Yeah.
Does that make sense?
Yeah.
So then we try with 2. And now our n becomes 5 minus 4 equals to 1. This will be G of 2.
And it gives us the output is
G of 2 is this.
G of 2 is 2.
Right. And 2 is greater than this one, right?
Yeah.
So we know that 2 will be in this place. Our answer will start from 2.
Yeah.
Now we can fix 2 and place 1 here. And calculate G of 1 here. G of 1 is 1, right?
Yeah.
And 1 is same as this. So we can place 1 here as well. Then we place 1 here and we have reached our answer. Is it making sense?
Yeah.
Or you do not understand something?
It's making sense.
Okay. So can we implement something in this?
Yeah. No. I'm not really sure why the number has to be greater than the number of thingies.
Okay. Let's look at the first thing only. Let's place 1 at the first place. How many ways are there to make 3 sum?
With 4 ways.
Right. So if you have 1 in the first place and there are 4 ways to make the rest of the sum, then our answer cannot start with 1, right? All the ways that are covered by 1 will be less than the answer.
So in that we can prune the things that we don't need.
Exactly. We just prune that branch.
Yeah. So.
Then we place 2 here.
And yeah, we get 1 and which one do we want? So we want the which link? What's the n in this case?
N is the like the number that like we have x. Okay, if I write it generally n and we place for I equals 1 to minimum of 10 comma 9 comma like this will be part with minus s now plus 1. We can do something like y n if g of n is greater to sum, not sum. If g of s, one second. If g of s minus I is greater than equal to n, okay, there will be an answer that we have to maintain. Then answer dot of n I s minus equal to I, else n minus equal to g of s minus I, something like this, I think.
So
is it not making sense at all?
It's making sense now. It is making sense.
Okay.
Okay, so we can switch to
Can we
editing.
start like implementing it then?
Yeah. And yes, let's name it G. Okay, first. Then define solve of s comma n comma this is s n and or the other one. I mean, not S and N.
Maybe s and n are required.
Yeah. Wait, actually, it's S. Actually, I'm pretty sure only S now is required because we already have S and N because they're global variables. So then, if yes now.
So this is not a cursor function. This is just like you can just write it globally only.
Okay, so then our answer is that, then I'll have to do it over here. So answer is that. So while n for I range of 1 to then 1 to, and then the minimum of what we want is n minus s, I think, plus 1. And also 10. And if g of s, zero, s, comma, no, not comma, there's s minus, yeah, I think we'll also need to store the index. If that is more than or equals to n, then it's answer that. If it's more than n, then that means that we can use it, so that's append of then, and then after we do that, we need to update our s, and I think it's,
we also need to update our n, not n, only s, right?
yeah, and I'm pretty sure, I think that's supposed to be an s, so then otherwise,
Yeah, it will be n, I mean, like counting the number of ways.
And if we need to update, just need to then it will be an infinite loop, because whenever, because
We'll be placing it on n, right? Like in the else part, n minus.
Oh yeah, so n g of s, and is it minus I or just s? Because
It should be minus I.
yeah, because this.
Okay, after you have appended, okay, let's find this one.
So
after we have appended, we can just like remove, like we can break out. We need to run it again for the next index.
And wait, after we update S, I think. Break. Yeah. And then I'll just go back here and then do that again. So print out. We don't need to print. Right, all we need to print is the answer. Okay. I forgot about the DP argument.
Okay, there has to be an issue here. Can you like print N every time?
Let's stop that. And let's run that. Oh, enter 5 enter. Right, so yes, it's always 4. So it's supposed to be answer that. Right. Let's add a breakpoint over there to see if it.
Oh, it will be while less only, I think. Yeah, you were right.
Right, so 4 and 5. Is it still doing that? And it's never entering the else part, and I guess that's was. Wait, let's I'm gonna run it again. Yeah, definitely.
Like, I'm not able to find the code clearly.
Okay, well, you can.
Yeah, now I can. I'm looking at the stream, YouTube stream.
If you want to make it. If you want to make the stream if you want to make the stream higher quality, then you can just click on the settings thing and then pick quality and then just pick the highest one. It should be 1440.
It's just showing 70. And I'm not able to change the quality.
Okay, so
okay. So if we have let's say 4 and 5, so while sum, okay, for I in 1, if g of s minus 1 is greater than or equal to n, it has to enter the else part, no? Can you write n minus, on line 23, can you write just break or something like that? Like not even break, just like print hello and then exit.
Print hi then exit 0.
It will be indented.
What will be?
Yeah, line 23, 24, they will be indented. I just want to check if they're even entering the else block.
Okay. I already checked that because with the breakpoint, it stops saying it stops it immediately if it touches, like, if it goes to that point, and yes, it didn't, but I'm pretty new to breakpoints, so let's just try like this, just to make sure. It is definitely that. Imports this. Sys.exit 0.
Okay, you saw breakpoint for it. Okay, now I get it. Can you check what G of 3 is given?
G of 3.
Okay, it's going to the edge of.
Yeah. Yes. Let's just print G of 8. It's going to be N is, it's just S is 3. Let's try. Come with that.
Only value of S matters.
It outputs 4. Okay.
It gives 4, right? Yeah, so it's working fine. Cool. Now, I want N to be printed twice, so what we can do is just print N. Yeah, just run this now once.
Over here. Line to
yeah, just run this.
4 and 5. Okay, it's definitely alright. Wait, let's do 6.
Okay, why is it 4? It should be 1, right?
Let's just have it. Let's just do. Let's do something like that, so then we can distinguish the else statements from the while statements. So,
it just goes to
yeah.
N is not changing for some reason.
And I guess it's only entering it once. Wait, just okay, that did not work. Wait, so
can you make an like a global I, not an I, like let's say X, and just declare a global X.
Yeah.
X equal to 0.
So
let's just run it for 3 iterations and get all the output. So you can print NNS on line 16.
Line 16. And then X or NNS.
Yeah, and under line 24, just like write if X is equal to 3, then this break.
Okay. If X is 3. If X is 3. Break Yeah, we
Not
forgot
break, just exit the program.
we forgot to let's just .exit. Let's .exit and import this. And also
And increase the X every time. This should be outdented as well, like 25%.
what should be outdented?
26, 27 should be outdented ones.
Okay, like that.
X plus equal to 1.
Not this X. Oops.
And on line 17 you have to print N comma S, not X.
Line 17. Print out N comma what? No. Print out
S. S for South Africa.
Okay. So let's try it. 4 and 5. 5, 4, and so it's like there's only one time when it enters that else statement, I guess.
Okay, even then N is updated to just 4. Whereas it should be updated to
Yeah.
1.
Yeah. So what?
Can you see what I well?
What so
Were you saying something?
no.
Okay. Answer. One second.
And this
Can you also print N comma S comma answer?
N comma S comma answer. And over here I'm printing out I as well.
On line 17.
So it's 5.
Yeah, printing I will be good as well.
Okay, so that's
There is an issue here.
1. So and S is 4.
S is 5.
I think I might have got.
N comma S is.
I think I got that the wrong way around.
Oh, sorry, S is 4 only. Yeah. Yeah.
The other way. S and N.
No, it was 5 only. It was 5 only. S comma.
And
4 or some S.
so is that 5 or 4? Right, and go to the question. I mean no.
It was S comma N only.
Right.
Some comma N. Okay, for I in there, this comes to 1. Print I पे मान वाला. Can you print G of S minus I as well?
1 second.
This is weird.
Wait, the question says that it does S then N. So print
Yeah, it is fine.
P off S. I'll go this.
Can you print it? No, not here. Like where you have written print N comma N line 25.
over here.
Under that, yeah.
I think we should do that, so then we don't need to add the arguments again. So it's 1. So g of s is 1. So then 4. Wait, n.
Here's an issue, right?
So n was 5, and then it was updated to 4. Yeah, yes.
But it should be updated to 1. S is equal to 5. I is equal to.
I is 1.
S is equal to 4 or
I is 1.
Yes, it should be calling g of 3, right? Can you print s minus I as well?
Wait, I'm pretty sure I know. It's because I'm pretty sure that it's because so the g of s, so g of s minus I, that it for the function, that means it starts from s minus I, so and yes.
Oh, right. We should always be calling g of 0 and our s should be made accordingly. So that's a good catch.
Okay, so I'm pretty sure we can do that. So let's put that at the end actually. Okay, so then but it's defined over here. I just put that over here.
We know the general direction that this will go, right?
Yeah, so g of 0, comma s is, and then s minus I. Wait. Right. Now it thinks that that is actually 7 for some reason. Okay. I think we're a bit late.
Yeah.
Do you want to? So, do you want to carry on later?
Yeah, okay. I'll help you out with the code as well.
Okay. So,
We're approximately at the correct solution, G according to our understanding.
yeah, we only got a bit of. We only got probably some tiny bug in the program. So
Yeah.
Thanks for watching, viewers. Even though I don't even think there was anybody watching. Let's just. Yeah, I guess there were some people watching actually. Wow. So now let